Hello, Integrated Math 1. Welcome to lesson R.7-1B. We're going to continue graphing systems of equations. This is day 2. Now, last time we talked about how to graph your equations. You can see if they intersect once, if they intersect all the time, infinite solutions, or if they don't intersect at all, like if your lines are parallel and they never intersect. So we had one solution, infinite solutions, and no solutions. Not really a surprise to us. But that also meant if we had one solution, it was consistent and it was an independent system. If we had infinite solutions, it was consistent and a dependent system. And of course, if it was parallel, they didn't intersect at all, no solutions, we said it was an inconsistent system of equations. So we played with that yesterday without actually graphing stuff. Stuff was already graphed for us. But I did warn you that today we're graphing. So today you need paper. You need graph paper, not just any paper. You need graph paper. You can't ghetto graph these things. They need to be precise. So you need graph paper. You're going to want a ruler or a straight edge of some kind, as well as your pencil, just to help you keep things precise. You'll see why you want that in a little bit. So if you don't have those things, go grab them and come on back. In the meantime, we're starting off on page 389 in our revealed book that we're piloting. And yeah, we're going to solve our system of equations by graphing them. So instead of just saying it has one solution, infinite solutions, no solution, if it has one solution, we're going to say what that solution is. Yeah? So you can solve a system of equations by graphing each equation carefully on the same coordinate plane. And you do want to be careful. That's why we're going to use graph paper. That's why we're going to use a straight edge. Keep these things nice and precise. And the solution of a system of equations is the point at which the graph intersects. So if you're like, oh, that point is at 3, 4, there's your solution. In fact, let me show you what I mean. Here, I have graphed two lines. I have two graph lines. So I have y equals x plus 4. And in case you just needed a little reminder, a little help, remember you can put a 1 in front of your x. And so there's my y-intercept at 4. My slope is 1 over 1, so up 1 over 1. And we use our straight edge to connect the dots. For my other equation, I have y equals negative 2x plus 1. So my y-intercept is 1. My slope is negative 2 over 1. So I have to go down 2 over 1. Use a nice straight edge to connect the dots. And if you look, you can see that this is where they intersect. So for this particular set, because I have to go back 1, that's a negative 1, and up 3, that's a positive 3. So my solution to this system of equations, if I were given y equals x plus 4 and y equals negative 2x plus 1, and I graphed them, and I was like, hey, that's where they intersect. The solution is a point. It's negative 1, 3. That's my solution right there. Yeah. So with that in mind, I would like you to solve this system of equations. Example 5, I would like you to graph the system and determine the number of solutions that it has. And if it has one solution, you need to determine the coordinates of that solution. So go ahead and hit pause, graph these out. If it has one solution, see where it intersects. And if it's just intersects in one place, tell me what that one place is. So go ahead, hit pause to work this out, and then hit play when you're ready to check your work. All right, let's graph this thing, shall we? So I'm going to use my red pen to start off with. Let's use the red pen here. So it looks like my y-intercept is at 14. Oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I go off the graph a little bit, but you get the idea. My slope is negative 2 over 1 because it's rise over run, or in this case, it's negative, so I guess I go down. So I've got to go down 2 over 1, make my next little point. This is where I bust out my ruler. And you could keep making points if you wanted to, right? You'd be like, another point and another point. You could do this forever. But I'm going to go ahead and use my straight edge, and I'm going to connect the dots and make my lovely line. Please use graph paper. Please use a straight edge. Keep it precise. All right, and I'm going to label this one that was y equals negative 2x plus 14, just so I can remember what's what. Let me graph the other guy. So my other guy is y equals 3/5 x plus 1. All right, well, my y-intercept is 1, so up 1. There's my y-intercept, make a little dot. My slope is 3/5, so from here I need to go up 3, 1, 2, 3, and over 5, 1, 2, 3, 4, 5, so right there. And again, I could go up 3 over 5, up 3 over 4. I could keep doing that, but you know what? I'm just going to grab my ruler and my straight edge, and I'm just going to make my line right through it. I'm going to label this. It's y equals 3/5 x plus 1, so I know where my stuff is. Now, remember that your solution is the intersection. So first of all, it only intersects in one place. It has one solution. And that place is right here. There it is. I made that really big. It's much bigger than it needs to be. But this is also why I want to make my lines precise so I can figure out those coordinates. So if I'm looking at this, it looks like I have to go over 1, 2, 3, 4, 5. So my x coordinate is 5. And then from here, 1, 2, 3, 4 units up. So it looks like my solution is 5, -4. Yay! Good job, us. We just solved the system of equations. If you wanted to, you could actually check your answer by plugging in an x everywhere you see a 5 and plugging in a 4 everywhere you see a y and making sure the two sides are equal to each other. You could do that if you wanted to check your work. Here, I'm going to erase this so that you can see the pretty tied down answer. Oh, it's so pretty. There we go. 5, 4 is the solution. All right, I have another one for you. This one's a little trickier. Sorry, but it is. This one's a little trickier because it's asking us again, graph the solution, determine the number of solutions that it has, and if it has one solution, give the coordinates. The only problem is these are not in y slope intercept form. They're not in that whole y equals mx plus b. So I'm going to recommend that you start by isolating the y. Solve each equation for y and then graph them. It'll make it easier. So go ahead and hit pause to work this out, solve for y, graph these guys, and then hit play when you're ready to check your work. All right, so by the way, we're on page 390 if you don't know where we went. I'm going to start with this one here. So -3x plus 2y equals 12. We had this happen to us yesterday as well, if I recall. So I'm going to add 3x to both sides. And I now have 2y equals 3x plus 12, since that is a positive 12. I'm going to divide everybody by 2. And I have y equals 3/2 x plus 12 divided by 2 is 6. So that's going to make that one way easier to graph. I'm going to grab another color here to help me do the other one. So I'm going to sort out this guy. Let's go ahead and subtract 6x from both sides. So I have -4y equals -6x, and that's a positive 8, so I'll put plus 8. I'm going to divide everybody by a -4. Make that go away. So I have y equals, we had this happen to us yesterday, -6 over -4. Well, negative divided by negative is positive, and I can simplify that. 6 divided by 2 is 3, 4 divided by 2 is 2. I have an x. 8 divided by a -4. 8 divided by a -4, I believe that gives me -2, right? I'm having a moment. But there we go. That's going to be way easier to graph. It's going to be way better to graph. And since my handwriting can be a little sketchy, I'm going to erase this and I'm going to show you the pretty version. Are you ready? I'm going to erase this so you can see all the pretty version. Go away. So there we go. That's a lot easier. So let's go ahead and graph each of these. So it looks like my y-intercept is 6. So 1, 2, 3, 4, 5, 6. Make a little dot there. My slope is 3/2, so down 3 over 2. Make another dot. Oh, sorry. My bad. Up 3 over 2. It was positive. My apologies. So up 3 over 2. Use my straight edge to connect the dots. For this one, I'll grab another color. So my y-intercept is -2, so 1, 2 down here. My slope is 3/2, so up 3 over 2. Uh-oh, you may be noticing something, and I'll connect the dots. Oh my gosh. Guys, they're parallel. They don't intersect. There's no solution. Boo. Fine. Fine, be that way. I see how it is. All right. All right. So that can happen. And we know that. That happened to us last time. So we're not really like shocked or surprised by that today. Sorry, I should be labeling my stuff, shouldn't I? So since these lines do not intersect, the system has no solution. All right. So here's the deal. You can solve, so you can actually use this trick to solve a linear equation. Like if you just have one equation and it has an x and just has an x in it, you can actually solve it by graphing it. Did you know that? You can write a system by setting each expression equal to y, and then you can graph that system and find the intersection. Let me show you what I mean. This is such a cool trick. We are skipping a little bit here. We are going all the way over to example 8, which is on page 393. So we did skip a little bit there, just so you know. We did skip 7. It's not your imagination. So we're going to use a system of equations to solve negative 6x plus 8 equals negative 4. And here's how this is going to work. I'm going to set each side equal to y. So I'm going to use the equal sign almost like a split there. So I'm going to say y equals negative 6x plus 8. And then I'm going to say y equals negative 4. Do you see how we did that? How we took our one equation and we turned it into 2. Yeah. And again, I realize you could totally just solve this, but I want to show you this trick because it's cool. Okay. And then what we're going to do is, of course, we're going to graph each system of equations. So we're going to graph this one. Y equals negative 6x plus 8. Well, that means my y-intercept is at 8. So 1, 2, 3, 4, 5, 6, 7, 8. Boop, put a little dot there. My slope is negative 6 over 1. So I'm going to go down 6, 1, 2, 3, 4, 5, 6, and over 1. Make a little dot there. And of course, use my straight edge to connect the dots. And then I'm going to go ahead and I'm going to graph this line. I'll use another color. And it just says y equals negative 4. So my y-intercept is negative 4. 1, 2, 3, 4. Put a dot there. Now, because there's no slope, my slope is 0. It's a flatliner, people. So I'm going to use my straight edge and I'm just going to flatline it. Oh, and we can see that it intersects right there. Now, here's the deal. Because there is an intersection here, okay? And we can see that intersection is at 2, negative 4, okay? But that's not quite what we're going for. We were trying to just find x. So I don't need both of these numbers. I just need the x coordinate. So the solution is the x coordinate of the system. So that means my solution is x equals 2. Bum, 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 bum. Now, I fully recognize you could have just algebraically solved this equation and it would have been a little less work. But I want you to see this trick. It's going to become useful in the future, so that's why I just want you to see it now. As always, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, please come talk to me. I'm around, and I'll see you guys soon. Bye.